The Arduino Nano RP2040 Connect board is one of the most commonest board for TinyML applications. And in this tutorial, we're going to be setting up this board for general purpose and TinyML applications. In the previous tutorials, we've been using the Arduino Nano RP2040 license, and in this tutorial, we're going to be switching and moving to Arduino RP2040 Connect. There are key differences between these two boards, but I can say that the knowledge is 90% transferable. The boards are both from Arduino, but the key difference I'm going to say is the microcontroller on board. For example, the RP2040 Connect board has a microcontroller that is based on the Raspberry Pi RP2040 Connect microcontroller. And I must say that's the key difference between these two boards. But also there are also some important differences like the type of sensors on board and also the mode of programming. But don't worry, if you have been using the RP2040 Connect board before, or you have been using the Arduino Nano RP2040 license, you can almost do anything like similar things on these two boards. But if it's your first time of picking up the RP2040 Connect board, we're going to be setting this board up and be seeing how we can program it for general purpose and also for TinyML applications. This tutorial will be in two parts. The first part, we're going to be setting up the RP2040 Connect board, set it up and do some kind of troubleshooting tips and tricks that you can encounter while working on the board. And the second part of the tutorial, we're going to be deploying a desktop-based control interface TinyML application on the board, just like we did in the previous tutorial, but in this case, we're going to be deploying it on the RP2040 Connect board. We're going to be training the model on the edge impulse, and after training, we'll be deploying the model on the board. And you can use the desktop-based interface to control almost anything, maybe a mobile robot, a drone, or anything at all. But in this tutorial, we're going to be using the gestures to control a YouTube video. But before we proceed, if you are yet to subscribe to this channel, please kindly do so by clicking on the subscribe button below and click on the notification bar so that you'll be informed whenever I release any video. So let's get straight in. Alright guys, we're going to do a little bit of overview of the Arduino RP2040 board before we go into the main programming and how to set the board up in terms of the software. But for the hardware, as you can see, I have the board here. If you look at it, there's not much of difference between it by physically looking at it and the Arduino Nano RP2040 license. Though there might be some noticeable differences. Let me bring up the other board. So this right here is the Arduino Nano RP2040 license, and here is the Arduino RP2040. Physically looking, where you can easily notice the difference is the processor on board. This is somehow bigger compared to the Arduino Nano RP2040 license. But we're not talking about this board today. We just go straight over to the RP2040 board. Now, the board has some sensors on board. I'm going to be showing you all the sensors. We're going to go to the website and see how the boards are arranged. And if you look at the back, depending on the type of sensor or type of board you are using, it will be written here Arduino RP2040 Connect. And the way this works is that on a normal day, if you connect your Arduino to your computer, if you connect the Arduino Nano RP2040 license, you're not expected to see anything when it comes to maybe a mass storage or a device has been plugged. You can only notice that something has been plugged when you try to connect the ports using the Arduino software. But in this case, it is expected that whenever you plug in the Arduino RP2040 Connect, it shows as a device connected to your laptop, as if you plugged in an external hard disk or a mobile phone to your laptop. So I'll just go ahead and plug this now, and I'll connect this to my computer. So I'm assuming if this is your first time of setting the board up, there might be some other things that we are going to do, and I'm going to be showing you everything and how best to get the guide. So now I've plugged in my Arduino to my computer now. So let's go ahead and see how the software is set up. So one thing I will do here is just go to my file manager. And as you can see here, this is my local disk and this is my internet. So there's no any form of other device connected to my laptop. So if this is how you experience it for the first time, you don't have to panic. It might be like this sometimes. You're going to be saying the way around it. But let me just go to the very beginning before I explain this principle. Now, we won't really go over talking about how this board really works one after the other. And best you can do is to just you can just search for Arduino RP2040. Arduino RP2040. There's an Arduino official guide concerning this board and it's well explained. I won't really go over each and every point there. I will just point you to some of the important things I need to take note of, and we continue in the tutorial. Here we have the Arduino Nano RP2040 official documentation, I will say. If you check the features, I might do maybe a side-by-side comparison with the Arduino Nano RP2040 license. But if you want to know about the 33-bit license, you can just check through the previous tutorial, or again just do a simple search of Arduino Arduino Nano 33-bit license. So if you do a search of 33-bit license, you also have the documentation where you can choose. But I'll go back to we have the RP2040, and you can see you can program the board using the MicroPython support. So it supports Python, and it has a microphone on board. That's a omnidirectional microphone. You have to be very close to it for this to work, and it has a 6-axis IMU. Now, this is one of the noticeable difference. The Arduino Nano RP2040 has a 6-axis IMU. It just has accelerometer and gyroscope, but the Arduino 33-bit license has a 9-axis IMU. Where is it written here? It might not be written, but you can see here we have accelerometer, gyroscope, and then magnetometer. So gyroscope and then accelerometer. But for the RP2040 connect, you only have accelerometer and gyroscope on board. And when you try to program this board, you are going to notice this. You're going to see it later on. So there's Bluetooth support and there's temperature sensor support also. So what the important thing is that, as you know, it can run some machine learning workload, which is what we're going to be practicing in this tutorial. Now, to learn more, you can simply maybe go to tutorials. You see a lot of guides for tutorials there, and I can just click here. One important thing I actually like checking first is the cheat sheet. The cheat sheet is going to give a lot of preliminary information you need to get started with the board. And if you want any individual tutorials or any individual guide, you can check this. And I'm sure just reading through this, you'll be good to go on the board. So if I click this, so there's some basic information explained. You can have your Arduino 2.0 or 1.0 as a microcontroller. Now, the first thing you have to do is that, as I mentioned, when you plug in your RP2040 board to your computer, it's supposed to show as a mass storage. It's supposed to show as if you connect your hard disk or you connect a laptop, you connect a mobile phone to your laptop. But when we plugged in, as you can see, I have my Arduino board plugged in. But if I open up my file manager, I'm not seeing anything. What I need to do is to go back to the guide. If you do this often, so you have know it offhand, you just find a way to short the rec and the ground pin, and at the same time you press the reset button. If I open up my camera field, so here we have the reset button, the white button on board, and turn it to the back. You might not be able to see this clearly, but I can see the rec and the ground pin. So the rec and the ground pin, if you turn your board in this direction, is simply just the third to the last and the second to the last pin. So to be able to do that, what you need to do is to short these two pins. I'll just place a meter on this, shorten the two, and then I will press the reset button. So with that, it opens up, and if I go back to my file manager, so you see that it shows that RP2. So with that visible, you are halfway done with setting the board, and you can go ahead and continue the program. So if you read through the guide, one of the key difference between the Arduino RP2040 and the Nano 33-bit license board is the way they are being programmed. To program the Arduino Nano 33-bit license, you have to write the code on the Arduino board and then upload the code to the Arduino. But you can do the same thing for RP2040 also. But another advantage or another opportunity that RP2040 gives is for you to be able to write the code externally, like outside of the device, just like Arduino, and then dragging and dropping the code file into the board. There are different ways of doing this. If you're using the Tony IDE, or you're using maybe OpenMV camera form of programming, or you're using the direct conversion from the Python code, just dragging and dropping the Python code into, if you're programming with MicroPython, you can just drag and drop from your computer and then drag it onto the device. It's going to automatically read it as the main file. You can read more on that, on how to get that set up. But first, let's look at the art of dragging and dropping just a file. For example, if you read through this, here we have a simple Blink example. You can see it's different. It's named in a different way compared to normal Arduino sketch. This is blink.ino.f.uf2. And let me just download this. So if I download this, I'll just maybe save it in my downloads, setups, and I can save it there. So I have it saved already. To be able to send a simple Blink program to my Arduino RP2040, I just need to drag and drop the file I just picked. So you can do your programming in this form, program it externally in this format. There are ways you can do that, and then just drag and drop it onto the board. And how do you drag it? Again, if I open up my, since that it's so much more faster this way than having to write the code in Arduino board, in Arduino IDE, and then uploading it to the board. But this might be faster, but it's much more easier and then much more common to do, to program it using the Arduino IDE. Most people are already used to the Arduino IDE, so they can just program it on the IDE and then upload it to the board. It might take some time, but it works. Now, can go to, don't forget this is my Raspberry Pi mass storage. I go to downloads and set up. This way I have the Blink file, and let me just, okay, yeah, I have it. It's blink.ino.f.uf2, so I can just drag this and drop it in my Arduino device. So I drop it here. So my Arduino recognizes it, it makes that sound, and that's just a simple blink to control the onboard. There's an RGB LED on the Arduino RP2040. The blink file I just uploaded is going to control that LED. So if I open this up, if I open up my camera field and show my RP2040, you can see that two things are happening. The original LED is blinking 1 second, and then the RGB LED is also changing color from red, green, and yellow. I think, yeah, it's different, changing to different color. So this one way of, for example, now I've uploaded a code on the RP2040 board, and then the code is running. So this is one way of programming the board, just by dragging and dropping. And you notice that immediately I dropped it, I can't see my RP2040 board here again. I can't see it listed under my devices again, so it's gone. For you to be able to bring it back up, you have to do what I did the other time by shorting the rec and the ground, and then pressing the reset button once. So this is one way of programming the RP2040 board, creating a UF2 file and then dragging and dropping it into the device. That's one way of doing it. So another way of doing it is just to open up the Arduino IDE and write any code you want to write and then upload it on the board directly. Another way, or should I say, the simplest way you can also program the Arduino RP2040 is to use the traditional method of programming it using the Arduino IDE. Before you can do this, you need to install the board, just like we did in the case of Arduino Nano 33B license. If you've set up your Nano 33B license on your Arduino IDE, you don't need to do this again. But if this is the first time of, maybe you are picking up the RP2040 as a first board for TinyML, you can just come to the board selection. If you are using Arduino IDE 2.0, you can just come to board selection and search for Arduino Embed OS. You can just search for Arduino Embed OS. So Arduino Embed. So you need to download Arduino Embed OS Nano boards. So this comes with the Nano, all of the Nano family, Nano RP2040, Nano 33B license, different type of Embed OS board for Arduino. But what you need to download is Arduino Embed OS Nano. You can see I've already downloaded mine, and if it is the first time, you have the option to install it here, just like we have here. So once you have the board installed, that's everything that you need to do. And you'll be able to select, once your board is plugged in, you'll be able to select from tools, board, and then you have list of different options here. So don't worry about these other ones. So the most important part is Arduino Embed OS Nano board. Here you have two options, whether Nano 33B license or RP2040 Connect. So I'll just select this, and I open up the Blink application as an example. Once I have that open, I can just upload directly on my board. Sometimes you might need to also select the board again here. But if everything's selected for you, you are just good to go. And I can just click on upload. So this was what I was talking about the other time. If you have the code in UF2 file, it's just a simple drag and drop, and then your code is done uploading. But in this case, no matter how little it might be, you still have to wait for the code to compile for it to upload before you can run, before you can see the actual results on your Arduino board. It might take a little bit of, it might take some time compared to just dragging and dropping the UF2 file to your Arduino board. And we have that done uploading. So you have that the code is done uploading. And let me open up my camera field and show you some other key difference between this and the other method. Now this is my camera field, and if I bring up my Arduino, you see that compared to the other case of the UF2 file, you only have the LED, the onboard LED blinking. The Arduino Blink example does not control the RGB LED on the Nano RP2040 board. It only controls the original blink. So this might not really be a problem. If you want to control the RGB, you have to maybe write another code to control that. But the blink example just control the LED built-in that is attached to pin 13. That's most times what you want to happen. That's most times the actual performance you're expected to see. So once you have that uploaded, you can see that the onboard LED is blinking, and that's how you can program the Arduino using the Arduino IDE directly. This will most times be the way you're going to program in the Arduino board. It's much more easier, and if you want a more robust or a more faster approach, you can just go through the approach of drag and drop. That's using the UF2 file. So now we are done with basic setup of the Arduino Nano Arduino RP2040, and we are done with the first part of this tutorial, which is how we can get up with the board, how we can get started with the board, and learn how the board works generally. If you want to learn more about how the board works, you can just again go back to this guide. Here we have the pin outs, just similar with the Arduino Nano 33 license, the analog pins, the pins. You can read through this. These are the sensors that we have. We're going to be looking at the sensor later on. Just check around how it works, and then I'm sure it's going to be straightforward to get the board up and running. Here, this is an example of if you want to control just the RGB. You can again write a code for only the RGB, and you see the performance on the board. So with that, I'm sure you now understand how the Arduino RP2040 works, and now you can get started with it in no time. So now let's go back to what we wanted to do in this tutorial, which is building a TinyML application and deploying it on the board. I'll now go ahead, open my engine pulse, collect my data, train my model, and deploy it back to the Arduino board. Before we go ahead and train our model and go to engine pulse, I think it would be good if you can test or look at how the IMU units on the board behaves. And to do that, I want to show you something first. If you look at the Arduino Nano RP2040, let me just go back. Now, look at the IMU unit that we have on board is LSM60SOX for the Arduino RP2040. If you check the Arduino Nano 33 license, you check the IMU sensor that we have on board is LSM90S1. This is one of the major difference between the two boards. The two boards have IMU sensors, but for Arduino Nano 33 license, it's using the LSM90S1, and for the Nano RP2040, it's used the LSM60SOX. The first thing you want to do is to download the library on your Arduino IDE. I've just come to my Arduino IDE link, and make sure you download the right library for the RP2040. You can just go ahead and search for LSM60SOX. You come here and LSM60SOX. If you check the different boards, this type of board, you see the one for the Nano 33 license also. But in this case, what we want to download is the Arduino LSM60SOX. Make sure you're downloading the exact one, not the Nano 33 license one. Now I have mine downloaded already. And once you've downloaded yours, you can just come to examples. And under examples from custom library, we're going to have the Arduino LSM60SOX. I can come in here and test for simple accelerometer, simple gyroscope, and simple temperature. Now let's take note, we only have simple accelerometer, simple gyroscope, and simple temperature. If I'm to check the sensor for Nano 33 license, you see that it has accelerometer, gyroscope, and magnetometer. But for the LSM60SOX, it only has accelerometer and gyroscope. Since we are going to be using accelerometer in this training, I'll just click on simple accelerometer. I will upload this, and we can view the results on the serial monitor. And after that, once we are sure that our board is well calibrated and we can read the accelerometer data, we just then go ahead and train the model using that data. So go ahead and click on upload. So that took around 5 minutes before it got uploaded. As I was saying, it do take some time if you are going to upload directly from the Arduino IDE. So to monitor that, I will open my serial monitor, and you can see we have the accelerometer data coming up. If I open up my camera field, and once I change my board orientation, we can see that it also changes on the Arduino serial monitor. So now we are done that, we are sure that the Arduino Nano RP2040 is giving out the correct accelerometer data. We now go ahead and use this data to train our model on Edge Impulse. If this will be the first time you are setting up Edge Impulse and your Arduino RP2040, there's some basic thing that you need to do before you'll be good to go. But let me just walk you through some of the basic steps. It's not complicated to do. I always like to point you to the original documentation in case you have any problem. You can easily go back there. The best way to do is just to search for Edge Impulse Arduino RP2040. I don't know, I always like going in this direction in case it's a simple Google search and you see what you need. So here we have RP2040 documentation, and it shows about if you want to connect the RP2040 board to the Edge Impulse platform. I'm going to be dropping the link to this documentation in the description. Now what you need to download is the firmware. You have to download the firmware for the RP2040. That's the Edge Impulse firmware for RP2040. If you take time to read through documentation, it talks about what you need to do. But most of the documentation is focused on Raspberry Pi Pico. But the Raspberry Pi Pico and the Arduino RP2040, they use the controller. That's the RP2040 board. You don't really have to worry about it. Even though you are using the RP2040 Arduino, you can still do the same thing. But what is applicable to Arduino Pico is applicable to RP2040. And it says here that using with other RP2040 boards. So there are other RP2040 boards that you can use. So I'll just go up and click on this. So once you click on this, download the latest Edge Impulse firmware. Now you're able to download the Raspberry Pi RP2040 firmware. So once you do that, I'll just click on save and download. So once you're done downloading, let me open up where this is saved. Since I'm yet to download that, again, latest firmware, and I'll click on save. So once it's done downloading, I'll open it up, unzip it, close. So this is what I'm looking for, the Edge Impulse RP2040 firmware.uf2. And what we're going to do is we're going to drag and drop just like we did while setting up the board in the beginning. And though my board is connected to my laptop now, it's not showing up on the list. You check it's not showing up on the list. So what I need to do again is to short the rec pin and the ground pin, and then I'll see it displayed on the screen. So you say after you download, drag and drop, drag the RP2040 firmware from the folder to the USB mass storage. So let me open this. I'm just going to short these two pins and press the reset button. So once that is done, we have the RP2040 now listed. So I'll just drag and drop this in drive E. Once that is done, we are ready to program our Arduino RP2040 and connect it straight to POSPO. So again, wait until the flashing is complete, unplug and replug your board to launch the new firmware. So I'm plugging it and then I'm plugging it back again. Now with that, we are done setting up our board to connect to Edge Impulse. Another thing you need to do is to set up your laptop to actually connect to Edge Impulse. And how you can do that is you need to go through the setup stage of Edge Impulse on your laptop. I won't go through the whole process. I've explained it in the beginning while setting up the second tutorial in this series. I explain how you can set up your laptop to connect to Edge Impulse. I'm going to drop a link to that. Quickly, if you want to go through that, you can just come up here and then install the Edge Impulse CLI. If I open this in another tab, it's very easy to go through. So you need to do this. It's very simple if you're on Windows, if you're on Linux, if you're on Mac, everything is explained. So you're done with this step, you can come back here and open your CMD. I'll just leave this open now, and from there we can connect to Edge Impulse. So once we know that we've set up our laptop to connect to Edge Impulse, and also we've drag and dropped the firmware file to the Arduino Nano RP2040, I'll just search for Edge Impulse, edgeimpulse.com. If you don't have an account, this will be the right time to create an account, sign up, and if you have an account already, just click on login. So you input your username and password, and you'll be good to go. So this is my account. For you to create a new project, just click on create new project. So let's give this project a name. You can call it gesture control, or anything at all you can call the project. So I'll call it gesture control, or let me call it RP2040, anything. I'll just click on create new project. Now this is the interface for the Edge Impulse. If this is your first time of working with Edge Impulse, I would recommend you take time to go through this read what's in some of the parameters that we have for some of the information displayed. I'm sure you're going to pick one or two things on how edge imports work. But the first thing I'm going to talk about is if you come to these devices, we see that currently we don't have any device connected. There's no how we can take our data. We need to find a way to get our device connected to edge imports. That will be the first thing we need to do. And how we need to do that is again to open up the command prompt and type edge imports daemon. So by now, I'm assuming that you've already uploaded the edge imports firmware on your Arduino Nano RP2040, and you have the edge imports command line interface set up on your laptop. So if I run this, this is connected. It's connected to my previous project. I'll just cancel and then restart everything from scratch. And now we do that is just to put option clean, and everything's going to start from scratch. Now you have to input your email address. This will be as if you are signing into edge imports freshly at gmail.com. And then I'm going to input my password. So once that is done, you have option to select your project. Don't forget we just created the project. Now gesture control. So I'm going to select this, and it's going to ask me the name I want to give to the device. I'll call this almost any name. Let me call it RP2040, and it says it's connected. If I go back to my project, we can see that on our devices now, we now have a project connected. We now have a device connected, and the name is this is the ID, and it gives me all this. If I come back to dashboard, I'll be able to see the name RP2040 that I give to the device. For any data, for any machine learning or TinyML workload, the first thing that we need to do is to collect data. And to do that, I'm just going to come to data acquisition, and then we can collect our data. There are different ways of collecting data. You can pre-collect your data using the Arduino board and then upload it to edge imports. You can collect it live, meaning you are collecting the data and then at the same time uploading to edge imports directly. And you can use different methods. You can use CSV format to collect data. You can upload data directly. If you click on add data, it gives you different method of uploading. You can have the data saved in a cloud bucket like Google Drive or any drive and then upload it to edge imports. What I'm going to do is I'm going to collect the data live. You can also use data forwarder. I'm going to be using that method in the next tutorial when I'm connecting the Raspberry Pi Pico to edge imports. So to do this, it gives me a list of my devices, and currently I have the RP2040 device. This is my device name. And now what I need to collect, I want to collect data for 3 different gestures: for circular gestures, for cross gesture, and then for pan gesture. I'm going to collect those 3 data sets, and then I'm going to collect a sample for when I'm not doing anything. That would be like the idle state or the ground state. The first I'm going to collect is the circle. That's if I'm moving the Arduino board in circular direction. So I'll call this circle. And sample length is how many seconds do you want to collect the data for. I'm going to, for now, put this as 20 seconds. Though I'm still going to split the data later on. I'm going to be showing you this. And if you select sensors, now this shows us all the list of sensors that we have on the board. We are not using the ultrasonic, we are not using the ADC. What we need to click on is the inertia. Let's click on this and leave this as it says as 100 Hertz, and I'll click on start sampling. Let me open up my camera feed and show you the start sampling. Once the sampling starts, it shows that I can move this in a circle now. So now it's good if you wait, let's say 1 second after each circle, so that it will give model opportunity to differentiate each circle. I'm moving this in a circle. Now, once the 20 seconds is done, it will upload the data and then we're able to visualize it. And this data we just collected. This is somehow very, very bad. Let me do it again. I'm not going to open up my camera feed in this case. Maybe it's somehow disturbing me. So let me just... So sampling at start. 1. I've moved my hand. 2nd time. 3. 4. 5. 6. And I'm doing the circular motion. So this can be, this not necessarily this is in circle, it can be any motion at all based on your application. Let's see how this looks. Yeah, this is much more intuitive and more easier to understand. If I open now, you have to note that I've collected the sample for 20 seconds. From here to here, we have 20 seconds. But I'm not going to be waiting for 20 seconds before my model will make inference. My model should be able to make inference after each cycle. So I should train my model on each cycle, not on 20 seconds window. So what I need to do is to click here and click on split sample. And I'll be able to split based on number of seconds I want. So I want to be able to split it by 2 seconds. That's 2000 microseconds, milliseconds. So you see that the window size expand, and I can just put it in a circle. And if you want to, for example, it automatically detects some of these distortions in the graph. These are not detected. This was not detected. So I can just click on add segment and just click on that particular point where I want a window to be dropped. Once I click here, it drops a 2 seconds window on it, and I can drag it anywhere I like. Again, I'll click on add segment and click here and then here. So if I count now, from just a single 20 seconds cycle, I've been able to take out 1, 2, 3, 4, 5, 6, 7, 8 samples. I'll just click on split and it will split it by 2 seconds. But now I'm going to have 8 samples. Now I have 8 samples instead of 1, but each of them 2 seconds. I'm going to train my model on this 2 seconds window. Now, one thing you should notice is that since we are using the IMU sensor, it takes the accelerometer in X, Y, and Z direction and gyroscope in X, Y, and Z direction. Though we're going to be using just the accelerometer, and I'm going to be showing you how to do this. But first, let's collect all our samples for the different motions. For circle, for panning, for cross, and then for idle. I'm going to collect 50 samples for circle, 50 for pan, 50 for cross, and 50 for static, that's unknown. And then after that, we proceed from there. Once we are done taking all the data sets, we have something of this nature. If you check here, we have the training samples to be 200. So we have taken 50 samples of circle, 50 samples of cross, 50 samples of pan, and 50 samples of unknown. If I click on filter your data, we have our filters that shows the number of samples I have for each label. And once that is done, one thing we want to do is to split our data into training and the test split. This is very important to evaluate our model and also penalize our model, whether our model is performing well on unseen data. If you just train our model on, if you train our model on all the data set that we have, we'll not be able to test whether the model can categorize unseen data very well or not. And this might cause some error in deployment. So what we need to do is to split our data into training and then test split. We use the training split to train the data, and then we use the test split to test whether the model can generalize to unseen data or not. And to do that, I'm going to click on this question mark, and then here it shows that we should perform train test split. I'll click on train test split and confirm this. So we need to also type in perform split to give this a confirmation. After that, I'll click on perform test split. And you can see that it split the data to 81% for training and 90% for testing. So once that is done, you can maybe check around and see how our data is structured. And you can see it takes the 6-axis accelerometer and the gyroscope. Next, once we are done and we are satisfied with the arrangement of our data, we need to click on create impulse to create an impulse. And if you check here, there are 2 parameters that we have here that we can tweak around. The first one is the window size. And window size is a 2 seconds window that we set for each of our samples. And window increase is 200 milliseconds. The first thing we have to do is to add the processing block. And for our kind of data that's based on spectra, that's based on waves, frequencies. So what we need to select is spectral analysis. I'll click on add, and automatically it's going to select the 6 axes that we are dealing with, accelerometer and then the gyroscope. For this case, I don't need the gyroscope, so I'll just deselect gyroscope in XYZ direction. You can go ahead and train your model with the 6 axes, but one thing I noticed is that the example that Edge Impulse gives to test our data set, to test our model at the end of deployment, only factors in accelerometer. So you might need to do some tweaking at the end of the day if you are going to train your model with 6 axis input. So for us to save us all that stress, I'll just go ahead and train with accelerometer. In case you need gyroscope, you can go ahead and train with gyroscope also. What we want to do for gestures, we are well enough training with accelerometer. And then after that, I'm going to then add a classification learning block, which is the first thing that we see here, and even the recommended block. So I'll click on add. So it gives us the 4 features that we are training on: circle, cross, span, and unknown. I'll click on save impulse. And after setting our impulse, we click on spectra and a spectral feature. Here we don't really have anything to do. We can just go ahead. You can change the parameters and see how it affects your model. But I won't really stay much time. I won't really stay much here. I'll just click on save parameters and generate features. And once that is done, it will show our data in different segments. And we can see that our data quite segments well. Everything that we have here is cross, and what we have here is pan, we have unknown here. And if you check closely, for circle cluster, we have a little impurity, just one unknown. This might be due to how the data was collected, but we should be well enough to train our model with this. So once that is done, I'll click on classifier and then go ahead and train the model. This way we have the option of tweaking the parameters to how we want it. If I go ahead and train on the default parameter, we have 30 epochs and 2 layers were created. That's the neural network layer. We have 20 neurons for the first layer and 10 neurons for the second layer. I'll just go ahead and train with this. If I'm satisfied, I'm going to carry on and deploy. But if I'm not satisfied, I might tweak some parameters to better aid the model's performance. And after training, we have 97% accuracy. If you are satisfied with this, you can just go ahead and deploy. But let me also tweak some parameters and see whether the model performance is going to improve or not. One thing I'm going to do is to change this to maybe 100 or 50 or anything. It can be 50, it can be anything. I really like you if you can experiment with this and see how it changes. Also, I'm going to add a dropout layer, maybe 0.2 dropout, and then in between the first layer and the second layer, and I'll go ahead and train. Again, this is actually if this is an academic research, you might have your architecture design before coming to Edge Impulse. But if you don't have that formally designed, you can just maybe play around with the layers, but you have to make sure you prevent overfitting, and you can test that with the test set. But as much as possible, try to avoid overfitting. At the end of the day, I saw that I was able to get 100% accuracy. So this might be due to overfitting. I can't really say until I test the model and see how it looks like. So to test the model, you can just scroll down over here and then click on model testing. And we're going to use the test split to test our model's ability to generalize well to unseen data. Again, I'm going to click on classify all to classify all my test samples. Oh, how good is that? We're able to get 100% test accuracy. And this shows that our model is going to perform well to unseen data. And after deployment, you see that our data quite generalizes to new dataset that we are taking on the board. This might not be true. Most times when you are after deploying the model on the device, you might not really get 100% accuracy because there might be a lot of reasons for this. The most important part is how data was collected. For example, if there's a little bit of tilt while taking the data for training, and the tilt is not there while testing the model, you may not really get the same results as when you train the model. So the model was trained. So if most time you are unable to get perfectly the type of inputs that we used for training while testing, so there might not be 100% accuracy while testing the model. But if you are able to make sure that the way the data were collected for training is the same way they were being collected for inference, you most likely get 100% accuracy also. And what I used to do for me to be able to test this is to test first on Edge Impulse. And to do that, I simply have to come to live classification. I should be able to use my board to test and see how my model perform. You can use a pre-trained example to test, but in this case, I'm going to just take a live sample from the board and then test it using the model. So I'll click on start sampling, and then I'll bring up my camera field. So the sampling has started. Let me test with pan. And it's going to upload, and let's see how the classification will be. So this is spanning, and as you can see here that we are not able to get, I won't say we get 100% accuracy. You see, most of the predictions is shared between circle, cross, span, and unknown. And you can check, most times we have larger percentage falling on pan and sometimes on circle. I think one of the reasons for this is how I took the data while training and how I'm taking the data now while testing. Most are able to get the perfect angle on, if you're able to get the perfect angle, the way you train the model is the same way you are testing. I think you should be good to go. So now let me sample the model using circle. I'll click on start sampling and let me bring up my camera feed and see how it performs for circle. And let me scroll towards the end. That was when I began to get perfect circle. Yes, as you can see here, towards the end, I was able to get, most times, larger percentage falls on that circle. And our model is going to predict in all of these scenarios, predict that our gesture is circle. So when we are sure, now that we are sure that the model perform quite well while testing it live, you can go ahead and click on deployment. And to do that, I'll just click on deployment. And it's going to ask me, I should search for deployment option, that on which device do I want to deploy this. You can search for RP2040. So it says a binary containing both edge imports and release, and then I'm going to click on Raspberry Pi RP2040. It also gives me that this is my device, so I'll click on this and click on build. Now once it's done, it will give me opportunity to download the model. I'll just save this in desktop and save. And then it shows me how I can upload the model on my board, just like what we did before. It compiled it to a .uf2 file. Now one thing, I'll just go ahead, I can go ahead and then deploy the model on my board using this method. And I'm going to do this. But one thing I also want to show you that I'm going to compile this for a normal Arduino because I want to be able to tweak some of the parameters there and use that to control my device. Yeah, it's not that easy for me to change a .uf2 file. So I need to compile again for normal Arduino and then upload it using the normal Arduino method and edit some parameters in the code and then upload it so that I'm able to use it to control my device. Or maybe if you want to use it to control a YouTube playback, as we are going to do in this video, we need to be able to edit the code, the original code. So instead of deploying to Raspberry Pi, which I'm going to test that, I'll just deploy as normal Arduino library. Click on Arduino library and then I'll build this. Since we know that we can also program the board using the normal traditional Arduino way. Once that is done, it will allow us to download model. Again, I've saved it also in desktop. And with this, we are ready to go on at our Arduino code so that we can send the signal to the serial and use that serial to control a YouTube playback. Now, we have two different things downloaded. The first is the Raspberry Pi RP2040 mode of operation, that's using the .uf2 file, and then we have the normal traditional Arduino way of programming the RP2040 board. So the first time we do is to go through this method, and I won't really recommend this, though it depends on what you are doing. So if I open this up, so you can see that inside the zip file we have the .uf2 firmware. I'll just extract this, okay, and I won't extract the other one. I have to import this into Arduino as a library, so I won't extract this. But now I've extracted this, and you can see it opens up. Where is it? Yeah, it opens up here. So the same thing, I'll just drag it and then drop it into my mass storage. So what I need to do is to just simply, again, I'm shutting my Arduino now and pressing the reset button. So with that, I have the Raspberry Pi displayed. So I'll just drag and drop here and drop this here. So once that is done, it's very fast. We are done uploading it. To view the inference, in a normal day, if you want to, after uploading a code on Arduino, you just have to open up serial monitor. Though we can still do that in this case, but when I was trying to use the Arduino serial monitor to monitor the response, I wasn't quite getting what I want. So I'll just open up command prompt. And from the official edge impulse guide, to view the inference, you just have to type edge impulse run impulse. Edge impulse, run impulse. So it's going to look at the devices I have connected, and then it will start the inferencing. So we have it's connected, and then we can see the inferencing. Yeah. So it says circle, cross, span, and unknown, and it gives me the percentage of each of those classes. For example, now I'm not doing any movement with my Raspberry, with my Arduino. So it says unknown is 0.99, which is 99. And one thing I discovered too is that the prediction is quite very poor, though I'm moving my Arduino in pan gesture now, but still I'm getting the prediction to be unknown. So one thing I discovered, one problem I think this is due to is because we train the model just using the accelerometer data. We deselect gyroscope, and also yes, we deselect gyroscope. That's what I'm thinking is the problem, and that's most likely the problem. So if you train your model using the 6-axis, you shouldn't have this problem. Or you can just try this and let me know how it turns out in the comment section. But as I said, I'm not going to be using this because I'm not able to get the perfect prediction. It's trying to use the 6-axis while I build the model using 3-axis. So I've just closed this and then open up Arduino. So I open up my Arduino, and then I'm going to just come to sketch and include library, include .zip library, and then I will look for the library I just downloaded, which is this particular EI RP2040 Arduino, and then open. Once we are done, the library will be uploaded on the Arduino IDE. Once the library has been installed, there are a couple of things that we need to do to make sure it actually works. I don't really know why this doesn't work out of the box, but it doesn't. In case if you are watching this video in the future and then everything that's been adjusted, you don't need to do this correction. But then let me just tell you what we need to do and why we need to do it. If you come to examples and scroll down under RP2040 inferencing, we have examples from Edge Impulse here, and then I'll come here and choose RP2040. So we have microphone continuous. What I want to choose is fusion. If I open this up, we're going to take note of some things, and then we make the necessary correction. Let me maximize this. So we don't really need to worry about everything. Yeah. So the most important part is the last bit of the code. Let me just close this. So the last 2 bits of the code, where we have defined edge impulse classifier sensor. Now we see that the first condition was edge impulse classifier sensor if it's not equal to fusion, and then if it's not equal to accelerometer. So those are the 2 things that we have, meaning that even though if you study the other part of the code, it seems fusion, every sensor on board is being integrated into this single code. Whether you want to do microphone, temperature reading, or accelerometer, everything is being integrated into this single code. But what we're using is accelerometer. So that is what we're using. Maybe it's fusion or accelerometer. That's what we're using. Now, take note of this. Then if you just open up your Arduino, if you go back to where your libraries have been saved, for me, if I come to documents and then Arduino, it might be like this in your own case too. And then I come to libraries. I'm going to see all my libraries. And the library I'm interested in now is RP2040 inferencing. If I click this, and then you go to SRC, and then go to model parameters, and then to model metadata. So if I right click on this and open it with Notepad, so let me maximize this. Now, if you just scroll down, you can do a search, but if you scroll down a little bit, if you scroll down to this edge AI classifier sensor, I've actually made this correction. What we have here originally was microphone. So I think I've made the correction before recording this. So what we have here originally was microphone. Just take note in case you are seeing microphone in your own case too. So just remove what we have here and change it to microphone. Mine was formerly microphone before changing to accelerometer. And also, we are going to have here the accelerometer and then the gyroscope. You can just delete everything until you have just three axes. Accelerometer in Y, X, Y, and Z. So you can delete. If this is the original code, well, let me just, you know what, I'll just open up the original code. I'll just skip through it and open up the original code. So this was what I have originally. you scroll down here, as you can see here, we have microphone. So we have under AI classifier sensor, what came with it was microphone, and it has these 6 sensors attached. So we are going to just clean this and change it to accelerometer, and then clean the gyroscope axis until we have just the accelerometer axis. So those are the two corrections you have to make, and then once you are done with the correction, you can go back to your Arduino, open up the edge impulse inferencing for RP2040 like we opened the other time, this, and then we click on upload. So I just wait for this to finish uploading, and once it's done uploading, you have something of this nature that says that cannot perform port resets, and don't worry, everything has been uploaded with this. And with that done, I've just opened up my serial monitor, and then I have inferencing. So one good thing here is that everything works perfectly. It picks the motion directly, unlike direct inferencing using the command prompt. Now my Arduino board is idle, so I'm having unknown. So I'm moving the Arduino in pan motion, and then you can see that on the screen it shows that panning is now 97%, and every other thing is 000. So again, let me change to cross motion. Now that is cross, and we can see we have cross to be 99% and every other thing to be 0. So we can do the same also for idle, that's for unknown, and then for circle. So with this done, we just make some few corrections, and then we do some adjustment to the code so that instead of sending this whole bunch of messages, we just want it to send what the prediction is, whether it is cross, pan, or circle, and we are going to use that to control a video playback. The last adjustment we have to make is to make sure that the only thing we are seeing on the serial monitor is our prediction, and we don't want to see any other parameters that might hinder our prediction. So I'll just comment out to this. For example, this is just showing the DSP results, the numbers of anomaly, and I don't want to see this. I just want to see my prediction. Also, there are other areas where it shows some other things that I might not really need. There's a place that it shows sampling, as we saw on the serial monitor. For example, here it prints out the sampling, so I'm still going to comment this out. And going back down, we just comment out the last part, and here it shows the classification for each of the classes and then show their percentage. I don't want to see that. I just want to see the class with the highest number, the highest percentage. So if I have pan to be 99%, I just want to see pan. I don't want to see the numbers. So what I will do is that I'm going to create another variable here. Also, I don't want to see prediction, so I will comment this out. I'll create two variables here. One is going to be a floating point, and this is going to be max value. I'm going to use this to check. You can call it 0.0 for now, and then you can create another one of u int 8, or maybe a u int 16, and then we call this the max index. So this is going to be used to check which index gives the highest value. You might not really need this, but for debugging sake, I'll just put this there in case you want to later use it. Again, I'm going to delete these two lines, and then instead of printing just the two numbers, I'm going to be printing one using an if condition, and it's going to be, since what we are taking is result, if I uncomment this, you see that our major value comes from result dot classification. So again, what I'll just do is delete this, and have if result dot classification. So dot value now is greater than the max value. Initially, the max value is being set to 0, so this will stop it from running. So if it's greater, and then I begin to update the max value until I have the largest number. So I'll just update it max value equal to result dot classification value. So I can just copy this here and paste it in. Again, I'll just update the max index to move to the next index equal to I. So once this is done, then I'll just have to print out the max index. So once this is done, just put in, this is going to print out the max index. So after uploading this, what I'll have is just, if it's pan, if it's circle, if it's cross, or if it's unknown, I'll just have only the number. So I'll go ahead and verify this and then upload it. After uploading this, I'll just open my serial monitor, and let me also bring out my camera feed so that you can see. So now the Arduino is just I do. So and it's showing unknown. If I change this to the pan motion, so you can see that the only thing that we have on the screen is just pan. And again, if I change this to circular motion, so you can see that the only thing we have on the screen is just circle instead of the other things being uploaded. So with this, now we are getting unknown, circle, pan from our serial. Then we're going to create a Python code. We're going to port the serial to the Python code, and then the Python code will be the one reading the serial instead of reading it from the serial monitor. So whenever the Python code reads unknown, it carries out a particular operation. Whenever it reads circle, it carries a particular operation. Whenever it reads pan, it carries another operation. So now let me bring up the Python code, and I'm going to be dropping the link to the Python code in the comment section below. If I open it, it has been prepared already. I'll just walk you through how the code works. From file, open recent, you have the YouTube control. Yes. So I have the Python code here. It's very simple. It's going to read on COM, depending on the COM that your board is currently connected to. For example, if you check over here, you see that my board is connected to COM8. So you have to come here and change this to COM8. And then we're going to be making use of some keyboard shortcuts that's applicable to YouTube on a normal day. For example, if you're watching a YouTube video and you press the M, it's going to mute the video. And if you press the M again, it also unmute it. Again, if you press K, it's going to play and pause the video. And if you press Shift N, it's going to pan, meaning it's going to like shift the video to another one. So what we're basically doing here is that whenever a serial monitor reads circle, it press the key M. And whenever it reads cross, it press the key K. And whenever it reads pan, it press the key Shift. So again, let me just scroll up. So one thing you have to watch out for here is that make sure that your spellings are correct. If the pan on the Arduino code is spelled with capital, the pan on the Python too has to be spelled with capital to make sure things work fine. So again, before you do this, we're going to close the serial monitor so that it won't say that port is busy. I'll just close this up and open up the Arduino, and then we can run this. So it says run module. Now picking up so we have the circle, it reads circle. Again, I'm performing the panning operation now. It reads span. Then back to circle. Then cross. Since I'm able to get my cross perfectly working, but then that's not a big deal. So what I'll just do is I'll open up a YouTube. You can actually use any YouTube video that's for test. I'll just use the video from the last tutorial. And now let me open up my camera feed so that we can see how this works in real time. So performing the circular motion. Now what I need to do is to open this and then be active in the YouTube screen. So I open this up here and then open my camera feed just in another tab. And I'll make sure the two are both visible at the same time. So then I'll also click here. So the cross, the circle, so you can see that it's mute and then just one. So it's unmute it, and then it's mute and then unmute again. So now performing the pan, so you can see that it shifts it to the next video on the list. So that's basically how it works, guys. That's basically how it works. I'll close this up, go back here, and then go back to my Arduino. So though I'm just using this to demonstrate a simple control of YouTube video, you can use it for almost anything, maybe a robot, anything at all that you can think of, you can use it to control it. So that's it, guys. That's basically it. If you find any of this tutorial useful at all, don't forget to give me a thumbs up, a like, and then please share this video to anybody that might need it, and don't forget to subscribe if you find this content useful, and click on the notification bar so that you'll be informed whenever I dropped any tutorial. So if you're able to solve this, if you're able to do the same thing, please drop a comment in the section below, and everything I've used in this tutorial, both the code and also the necessary links, I'll be dropping them also in the description section. Again, don't forget to give me a subscribe before you go, and then I'll see you in the next tutorial. Thanks so much, guys.